Let's take a look at this example. We're supposed to find voltage between point A and B, D, C, between points A, C, and D, B. Very first thing which we're supposed to do, we're supposed to find total resistance first. Total resistance for the series circuit is nothing else than the sum of all resistors in the circuit. So I'm going to write R total is equal R1 plus R2 plus R3 plus R4. Remember, write formula first, always equals. And I have R1 is equal 2 kilo plus 4 kilo plus 3 kilo, and R4 is equal 5 kilo. Everything is equal 14 kilohms. This is the total resistance of my circuit. Next, I'm supposed to find V total. Total voltage. Why I have to find total voltage? Because I have three different voltage sources. Let me remind you one more time. Anytime we have voltage sources connected to each other by positive terminal and negative terminal, means you have to add these two voltages. V total in this case is going to be equal to voltage source 1 plus voltage source 2. This is my voltage source 1 and this is my voltage source 2. Many people get confused about connecting the voltage sources together. Just keep in mind that anytime you put the batteries in the flashlight, you put this in the order of positive to negative. If you are going to flip them and you are going to put them in this way, the device is not going to work. You are not going to see the light. And also, if you are going to put in this way two batteries, negative to negative, the flashlight is not going to work. Why? Because these two voltages are going to subtract each other, and you are going to have 1.5 volt minus 1.5 volt is going to give you 0. And anytime you are going to connect negative to negative, the voltages are going to subtract also, and the flashlight is not going to work. So remember, anytime you connect positive to negative, the voltages are going to add to each other, and anytime you are going to have like terminals, you are going to subtract. The long bar is the positive terminal and the short one is negative. This is positive, negative, positive, negative. I always start solving this kind of problems from the strongest power supply. In this case, I have 40 volts. So I'm going to start from this power supply. V total is going to be equal voltage source 1, and this power supply is going to push the current in this direction, and positive terminal is going to see positive terminal of the second power supply. Means these two voltages are going to subtract from each other, because positive goes to what? To positive. No matter how many resistors we have, positive goes to positive, we have to subtract voltage source 2. And this positive is going to be also connected to this positive. That's why I'm going to also subtract voltage source 3. Positive goes to positive. Positive goes to positive. You have to subtract the voltages. That's why I'm going to have V total equals voltage source 1, 40 volts, minus voltage source 2, which is equal 10 volts, minus voltage source 3, which is equal 12 volts. Everything is equal 18 volts. This is the total voltage in my circuit. Means I combine all voltage sources together. Next, I'm supposed to find the total current. I total, I'm going to find by using Ohm's law. Ohm's law says current is equal voltage, in this case total voltage, over total resistance. V total is equal 18 volts over R total, which is equal 14 kiloohms. This is equal 1.28 milliamps. This is the total current in my circuit, and this current is going to go in this direction, clockwise direction. Remember, anytime current is going to enter the resistor, it's going to label this terminal. Just imagine that it's going to be labeled by positive sign, and anytime it's going to leave, you have to put negative. Current enters over here, that's why I'm going to write positive and leaves negative. Positive, negative, positive, negative. Next, I'm supposed to find voltage across each resistor. I'm going to use, again, Ohm's law. Voltage across resistor R1 is equal I total times R1. Remember, this is series circuit. In series circuit, current at every single point is always the same. Just please keep in mind that I total in this circuit is equal IR1 is equal to IR2 is equal to IR3 and is equal to IR4. So if I'm looking for VR1, voltage across resistor R1, and I'm writing I total, it means that this is the same value as current which goes through resistor R1. So I have my I total is 1.28 milliamps times R1, which is equal to kiloohms. And this is equal 2.56 volts. This is voltage across resistor R1. Next, I'm supposed to find voltage across resistor R2, which is equal I total times R2. Remember, write always formula first. 1.28 milliamps times the resistance of the second resistor, 4 kiloohms. This is equal 5.12 volts. Next, I'm supposed to find VR3. VR3 is equal I total times R3, where I total is equal 1.28 milliamps times R3, 3 kiloohms, and this is equal 3.84 volts. This is my VR3. VR4 is equal I total times R4, which is equal 1.28 milliamps times R4, which is equal 5 kilo. This is equal 6.4 volts. I found all voltages across the resistors. Let's continue. Next, we're supposed to find voltage at each one of these points. Voltage between A, it means voltage between this point and ground. Voltage B is voltage between B and ground. C and ground, D and ground. Okay, so I'm going to say VA. VA is the voltage from this point to ground. I have to go from this point by voltage source 1 to ground. So I see first positive voltage source 1. That's why I'm going to say voltage A is equal positive voltage source 1, which is equal 4 volts. No matter in which direction you are going to go counterclockwise or clockwise direction, your answer must be the same. Always choose the shortest way to reach the ground. VB, voltage between point B and ground. I'm going to go counterclockwise direction. So I have point B. I'm going left. I see negative sign. This is negative VR2. And I'm going this way. I see negative sign. Negative VR1. And I see this time positive voltage source 1. I'm going to have negative VR2, negative 5.12 volts, negative VR1 minus 2.56 volts, plus voltage source 1, plus 4 volts. This is equal 32.32 volts. This is my voltage between point B and ground. Next, I have to find C, voltage C. I'm going to go this way. So if I'm going to go in this way, I'm going to see first positive. This is going to be my VR4. And I see positive plus voltage source 3. This is equal. VR4 is equal 6.4 volts plus 12 volts. This is equal 18.4 volts. This is voltage between point C and ground. VD is connected directly to the ground. That's why VD is equal 0 volts. VAB is the voltage between point A and point B. How we can calculate this? Simply write VAB is equal VA minus VB, where VA is equal 40 volts minus VB, which is equal 32.32 volts. This is equal 7.68 volts. This is voltage between point A and B. Next, I'm supposed to find voltage between point D and C. VDC is equal VD minus VC, where VD we found is equal 0 minus VC is equal 18.4 volts. This is equal negative 18.4 volts. VAC, to find voltage VAC. And I have VA minus VC, where VA is equal 40 volts minus VC 18.4 volts. This is equal 21.6 volts. This is voltage between point A and point C. Next, I'm supposed to find voltage VDB. VDB. This is voltage VD minus VB. So I can say this is equal VD equals 0 volts. VB is equal 32.32 minus 32.32 volts. So I can say VDB is equal negative 32.32 volts. We found VAB, VDC, VAC, and VDB. We found everything, whatever the problem was asking me. Okay, so these are the solutions to my problem.